So now, we're really pleased to welcome Hervé JEANJEAN for our last presentation of this afternoon session. So thank you very much for coming from Toulouse, especially to give this presentation in person. You are Copernicus Program Manager at the Centre National d'Études Spatiales, the French National Space Agency, seconded to the European Space Agency between 2017 and 2020, and to the European Commission between 2009 and 2013. You have a deep experience in managing research and development projects on Earth observation application and data exploitation. Graduated in agricultural forestry and environmental engineering, your career started in tropical forestry, management at the CIRAD, the French agricultural research organization working for sustainable development of tropical and Mediterranean regions. You were awarded by the Ordre National du Mérite Agricole, and you were auditor of the Institut des Hautes Études de Défense Nationale in France, which contributes to the development of strategic thinking on defense and security issues. So now come forward, come to stage for a conference about space sentinels, unstinting guardians of our planet. So the floor is yours.
Good evening, ladies and gentlemen. So I am the last, I have the privilege, if I may say so, that I have the last talk of the day, so I hope you are not too exhausted by so many interesting talks or so many interactions. So very, very interesting day. So first of all, I would like to thank the organizers for the invitation, for all the arrangements, travel arrangement and so on, and welcome also, which is a very warm welcome. Yesterday afternoon, the visits of the labs, which was for me also very interesting. So I'm going to talk about, there is a subtlety in the title, because you see Space Sentinels, so you know that this is the Global Change Sentinel session. Sentinel, you have to take it at two different meanings. There is the literally meaning, which is the way of monitoring the Earth. But this is also the name of the Copernicus satellites I'm going to talk about. The satellites which are called sentinels. So this is also a double meaning behind this. So in a way, I would like just to very quickly echo what has been presented this morning and today, this afternoon, in particular by our colleagues, on the challenges of global change and climate change. And this is also to take you and bring you take some distance from the Earth to the space to see what can provide satellites in this respect. So we've seen that monitoring and understanding Earth system is very key really to understand processes and modeling processes, and also to predict trends and evolution. We've seen this very nicely this morning, assessing human impact. And we see that these challenges are very linked to societal needs. And Wolfgang also presented these habitability challenges, which are completely linked to this. So we need, for that, we need observations. Of course, we have to run models, we have to develop models, and there is this question of complex modeling, sometimes simplistic modeling, but we see also a very strong evolution in modeling. We have also short-term modeling, we have the long-term modeling, climate modeling, which is really looking forward to decades and centuries, of course. So, but we need to feed the models, to test the models, so we need observations at different scales and temporal resolution. So ground, we have seen yesterday some very nice equipment here in the labs with drones equipped with sensors to measure carbon dioxide or methane, for instance. So this is very important. We need to combine all of this observation from the ground to the space. And space cannot run alone. We have to validate, calibrate the data with data from the ground, in situ data. So all of this is integrated. So in observation from satellite and in situ, we have the data, the models and data simulation. We have to measure these essential variables. And you know that among the 55 essential variables, it's about 35 which are addressed and can be observed by satellites. And we observe these variables over all the compartment of the Earth systems: atmosphere, land, ice, oceans, etc. And of course, all of this has to be integrated towards indicators, model outputs. We've seen the IPCC reports very clearly describe also the recommendation to public authorities or decision makers and also the grand public. So now, from that perspective, what is Copernicus? I don't know if you know well the program, but a few years ago it was not called Copernicus, it was called GMES. GMES is it's an acronym, so of course not well known by the public. And a few years ago, the European Commission decided to change the name. Copernicus has some, Copernic, of course, has some connotation, I would say. So it's probably now more well known, especially because we have the use of a number of indicators which are used by in the international forum. We hear about the observatory Copernicus on the trends on temperatures, for instance. We have a number of examples like this. So Copernicus is a program implemented and managed by it's a European program managed by the European Commission in partnership with the member states. The European Space Agency and EUMETSAT. EUMETSAT is the European organization for operating meteorological satellites. So for addressing environment issues and security issues. So what is very important, I think we have a limited time, but I will go quickly. So if you have questions, of course, we can discuss. But what you have to remember is that the very key element, the backbone of Copernicus is the provision of operational services with something operational means on a routine basis, every day, every week, every month. There is no interruption. There is really an objective to be fully operational. So this is addressing European and national needs, policy needs, and in the objective to manage and protect natural resources. Of course, there is this climate change, which is very strong in the objectives of this program, but also monitoring, providing some, let's say, some response to natural and industrial disasters. There is also the data policy, which is very important. The data policy is key in this program because it is based on a full, free and open access. It's for free. You can get the data, you can get the model output, just log in and you get the data for free. And I can tell you that there is, probably most of you or some of you know that, you have petabytes of data available now. And there is also some commercial or downstream, I would say, some development of downstream activities. So very quickly, the space component is managed by ESA. The in situ observations are coordinated by the European Environment Agency, and the services, I will talk a little bit more about that, the services are coordinated by the European Commission. All of this started 25 years ago, so it's a long way to go. I will not go through the different steps, but just to tell you that in this great endeavor, I would say, there is a need to look in the long term and to have some, let's say, visibility and a strategy. We are not in the next 3 or 4 years, but we are looking forward 15, 20, 30 years to maintain this capacity, and this is a real success. I can tell you that the effort for this is really, really important. And the Copernicus started the operations in 2014, so now it's 10 years ago. Very quickly on the governance, I wanted to mention this just to show you the importance of the delegation of the activities with a number of entities. You see the services in the middle, which are delegated to the European Center for Medium Weather Forecast. We have also Mercator Océan in Toulouse, which is also delegated the activities on the marine environment. And we have also, for the security services, we have also a number of EU agencies involved in that. Okay, I don't want to bother you with the figures, but this is only to show you that this effort is also with a huge amount of money injected in the program, but also not only for the space component, but also on the services and the research. The research has been absolutely key in the program since the very beginning. It has been also funded by the framework program of the European Union research program, FP6, FP7, and then ESA also is an R&D activity, so funded by member states, and it is growing, of course, with more and more capacities. So altogether, we are now in a range of 17 billion euros since 20 years. So what are these constellation of sentinels? We have quite an armada, I would say, which is a very impressive suite of satellites, which are monitoring the Earth every day, it doesn't stop. It's a very constant capacity. The full free and open is really key. And there you have all the different satellites. Again, I will leave you to look into this. I think this presentation can be accessed, of course. But for instance, okay, this one. Okay, if you see, there is Sentinel-1, which is the radar system. We have Sentinel-2, which is the optical one. Sentinel-3, there is both altimetry and optical sensors and temperature as well. 4 and 5 are embarked on meteorological satellites for the atmospheric measurement. And Sentinel-6 is the reference altimetry missions, which is the follow-up of JEANJEAN TOPEX missions, for instance. Very quickly to show you that we have a recurrent. When we build a satellite, we need to build a number of similar recurrent satellites so that, first of all, it's less expensive. So when we build 4 of them, it's the second, the third, and the fourth are a bit cheaper. And there you see in green the ones which are already running above our heads. The red one has been lost. So that means that, for instance, for the radar, we have quickly to launch the Sentinel-1C for avoiding any interruption of the service in the coming months. So there is still a lot to come, of course. Behind this capacity, we have another revolution is the use of a huge amount of data. Copernicus is the largest, number 1 in the world, producing this level of data, which of course, opens new capacities. You know, big data now is artificial intelligence. When we have a big amount of data, we build neural networks with the HPC capacity. We are really in a new era. It's really a game changer, I would say. And for instance, all land is observed every 5 days at 10 meters resolution. You can imagine the amount of data, and this is in more than 10 bands. So that is 25 terabytes of data every day, 365 days a year. So 3 terabytes of daily Sentinel products, which are the generation of from that primary data. We have also to produce a number of high-level products, I would say, which is also produced and disseminated to anyone willing to get the data. And more than 700, now it's about 800 users in the world. So I said that the research is very important in the design and the development of the program. Of course, why? Because we need one key issue, and the priority for the research community is the improved capacity, continuity for both observations and services. For observing subtle or low signal long-term trends, we need the long-term series. An example here is the sea level rise. And with this long-term data records, of course, we have to intercalibrate the satellite observations so that they can be interlinked, or we can build the long-term series. So we call it fundamental data records. We see the trend, and you have on the left here, you see the evolution of sea level rise, which is about the 3 centimeters per decade, 3 millimeters, 3 centimeters per decade, 3 millimeters by year. So since the 19th. So this is, of course, with an evolution. We had the presentation this morning on the long-term trend, so this is going to change. We need to observe at different spatial and temporal resolution, of course. We need the global observation, but we need also to sample in the time more frequently now. So you will see that we are trying to use other types of data. And we need also to address the interfaces, of course, of the different climate, the different Earth system, which is absolutely key, in particular, on the geochemical cycles of the Earth system. So there is also an evolution in the future with a number of new capacities which are going to be launched in Copernicus, and in particular, no, not this one. So, in particular, this one here. So this is a new mission which is going to measure the anthropogenic carbon dioxide in the atmosphere. And this is going to be launched in only 2 years from now. We have also a new mission coming up on the land surface temperature monitoring. We have an hyperspectral mission which is going to be launched also, which is called CHIME. A system on the L-band radar system to be launched as well. Another one which is on the sea ice concentration, which is called SIMMER, to fill the gap. And also CRYSTAL, which is also sea ice sheets, polar regions, to be launched as well in the next years. So all these missions will be completing the fleet of satellites to be operated by Sentinel. So you see here that we have a very big effort on Copernicus, but this is linked to science and meteorology. There are many links between the national, international corporations, the Earth Explorer missions, which are built by ESA. When there is a need to continuity and to long-term access to operational data, there is a transfer, I would say, to Copernicus to become an operational mission in the Sentinel. So the guarantee that we have the data for the long run. And you see the different payload also which are embarked on meteorological missions on the right. Here we have, I was telling you, mentioning the fact that we have the dedicated missions which are Sentinel, which are owned by Copernicus, but we need to complement the data with other sets of data which are commercial data or national missions, or even from non-European data system, for instance. And there you have here today let's say the panorama of those missions. And there is there are newcomers which are actually here on the right, which are a number of companies which are developing. They are called new space actors. You probably heard about that. They try to develop constellations, small satellites, so probably with a higher temporal capacity, so that they will complement Sentinel observations, which are used as reference missions, complemented by this new constellation. Of course, one or two satellites cannot observe. You see, for instance, Sentinel-2, it's every 5 days. This constellation, they can collect data every day, even several times a day. Now, a very quick overview of the services. We see that there are 6 services in Copernicus: climate change, marine monitoring, atmosphere monitoring, land, security, and emergency management. So there you see that if I focus a little bit on those different services, the marine monitoring, so the state of the ocean, but the blue, as we call it, the blue ocean, but also the white sea, the ice, and the green, the biochemical ocean. And this is done on global and regional scale. Okay, and there you have many products available on this service, whether for beginners or researchers, or even very, let's say, pro products, product for really advanced users. We have also the atmosphere monitoring, which is run by the European Center on air quality, ozone layer monitoring, emissions and surface fluxes, solar radiation, climate forcing. There these illustrations here were taken just yesterday as the forecast of today. So this is illustration on the ozone layer, the optical depth, and the, I think this is monoxide, carbon monoxide. I think the 3 illustrations are the situation of today, which are extracted from models as the forecast of today, 15th of February, 2024. Now, on the management of disasters, sorry, the title is still in French, but doesn't matter, you understand. We have here a service which is providing maps on demand, quick mapping, rapid mapping when there is a disaster, triggered by authorized users so that they can get the map quickly. Security services, I will go quickly. For instance, oil spill monitoring, frontier surveillance of border surveillance, and also support to EU external actions service, which is run by SATSEN. The land also is a very large service, monitoring a number of indicators. There is the land cover. There are also, you have an illustration here, which is there. You see the, I think this morning was mentioned, the artificialization, the imperviousness of the soil, which can be very well monitored by satellites. And the climate change service, which is a very important service where you have all the information that can be grouped together to provide indicators of the past, future climate in Europe and the rest of the world based on essential variables, reanalysis, seasonal forecast, and prediction. And there you have this one here on the last, on the right, below right. You see here, for instance, and again, this also was taken just yesterday. You see, but it's a bit small, but there you see a curve, which is the sea temperature, 2024, which is much above. So this is the record since the beginning of the year. And you see the comparison of this with the rest of the curves, which is really above the different the past years. So today, this year is a very is also we are also breaking records in terms of climate observations. Okay, very quickly, we are also addressing a range of issues behind the Green Deal. You all know about the Green Deal. And you see all these different actions or policies ranging from forestry to agriculture, pollution, water management, and so on. So this is really something which is done to respond, to provide information. Space, again, is not the answer. It's a tool to provide authoritative and relevant information to these decision makers and policymakers. Well, so Copernicus is the world leader for monitoring the state of the planet. I said number one. Of course, we have other systems in the US and in China, for instance. But this is the unique one which is so well, let's say, monitoring all the compartments of the Earth system. Really what I would like to highlight is this, how it was built on this capacity continuum between the research up to the services. And this is absolutely key. We could not develop services from scratch like this. We are building on a knowledge and an expertise which was developed for the last 20 years. So the scientific community is an actor of the definition of the system, but also a user. The principal user of Copernicus is the scientific community. All of you, some of you already are using Sentinel data, for instance, but you may use all this. The scientific community at large is the first user of this tremendous capacity. So trust and reliability is also a factor of success. Why reliability is that the products are of very good quality. We need to validate the products. I mentioned the CalVal activities using ground measurements, in situ measurements. So that's why we need these drones, balloons, airborne data. The transparency is key as well, and also the long-term visibility. We know and we have the guarantee that this data will still be available in 20 years, 30 years. For your whole career of a researcher, you can rely on the fact that you will get the data available for you in the next 20, 30 years. So no problem, you can count on it. It is also well referenced at international level. I mentioned this, and you have all seen these graphs showing the temperature trends with the last years. Is something which is very well done to show to the ground public that where we are in terms of this year compared to the previous years on this global evolution. Future challenges, I'm almost done. So we need to safeguard these operational priorities, which are improved continuity. I mentioned this as a really key. We have to, you have at least one thing to remember of Copernicus is this continuity, but with some, let's say, increased capacity in the future, but continuity is absolutely key. And the information access under this data policy, full, free, and open. It's for free. The public is paying for it. We are not going to ask the scientific community or researchers to pay for it. It's for free. But it's also for free for the world. So we have some questions today because, of course, there are big users on the US platforms, for instance, Amazon and Google. So there is this question of to which extent we leave this open without any barrier at the moment. Ensuring sustainability. This is a question because we see that with this increased capacity, now we are going to have 12 Sentinel families. So more or less doubling the capacity. So we need more budget to operate the missions. And in Europe, we have many, there is a very great ambition in space. Probably you heard about Galileo. Now we have our own European navigator, GPS, European GPS, if you want. We have this Copernicus Earth Observation Monitoring System, but we are also building new programs like IRIS². This is the communication and secure communication, but also for governmental services to be developed. So also launcher, and not mentioned here. There is also there are big issues on launcher capacity in Europe. So all of this together brings the fact that we are facing a new phase of increased needs for space in Europe, so with increased budget requirements. There is this question of make or buy. Do we need to own the satellites and operate for ourselves? Or do we just buy the service? We buy the service to get the data from commercial missions, for instance. And this is a question with a balance to be addressed between the two. We are not yet stabilized, but this is an issue to be well monitored, to be addressed in the future. Well, as a conclusion now, so I mentioned that this Copernicus program has an outstanding international success, which is well recognized. Relying strongly on previous and long-term research activities for observing, understanding, modeling, predicting, and also scenario analysis. In the scenario, we have today the development of digital twin Earth. There are a number of initiatives which are now in progress to develop this twin Earth, digital twin Earth, both from the European Commission and ESA. This unstinting capacity is a real game changer. From the past, we were launching systems running a couple of years in the sky. Of course, in space, the satellites is under very difficult conditions. It runs for a couple of years and then stops. And of course, now we are in this capacity of knowing that we can count on these sentinels for a long term. We are also behind other problems like debris, also mitigation actions, so to be addressed as well, of course. I mentioned this enhanced capacity and the Calval activities, and the final word will be to keep the services at the state of the art. We need to maintain the activities of research, and the research both on the, you have it on the right there, the research, both long-term research, which is of course to be done a little bit outside the services, but then there are within the services included the applied, I would say, development and research within to feed the operational services. So this is a continuum between the long-term research, which is actually today run at national level in different labs, universities and so on, but also funded by the European Commission. You have plenty of opportunities at European level to go through proposed projects to be funded by the EU in the frame of Horizon Europe, you know the program, to get funding for your research activities. So this concludes my presentation, so I will be pleased to answer a few questions, if any. Thank you very much.
Thank you very much. Congratulations for this presentation about Copernicus. These data are very important to understand better the climate change. So maybe, do you have a question? Nope. Sorry, excuse me.
Thank you for your presentation. Very impressive program, Copernicus. I have a question about the services. I see land services, marine services. I'm a lake ecologist. Now, I know there are freshwater services being developed within Copernicus, but my question really is, why is it not as visible as the terrestrial and the marine services? Because again, as a freshwater person, maybe 3 arguments why freshwater is easily as important. It's essential to all life on Earth. Already billions of people live in areas where fresh water is in short supply, and that's only going to get worse with climate change. And speaking of climate change, also freshwater systems, despite their small size, for instance with methane, play a very critical role in where the climate is going. So why are freshwater services not as visible as the other ones?
Thank you very much for this question, and this is a good question. Actually, I will tell you a small story. At the very beginning of Copernicus on the services, there has been a number of so-called fast-track services, something the quick wins, if you want, to be launched, and one of those was on water. But there has been a big failure in the consortium to provide, to answer the call. They just submitted the proposals a bit late. You know, you can submit and resubmit until a deadline midday. In fact, it happens that they could not do the latest version. It's a very stupid issue, but there has been actually, this was the only one because it was structured at European level, taking all the best actors at that time. And finally, but this answer, this proposal, could not be taken by the European Commission because it was too late. And then, Copernicus services started on the other sectors, especially on the other land components. There was also marine, which was very advanced, atmosphere, and so on. Security came later on. So what happens on water is that it was a bit delayed. So finally it came, there has been new products, as you know, and there is the monitoring today of water ponds and lakes and rivers, also using altimetry, so there are a number of services. But now there is the preparation of something more, let's say, integrated, so there will be some more advanced service on water. But you're right, this is absolutely a key issue. It's also an issue which is going much beyond the, let's say, daily life of citizens, but also it's a diplomatic issue as well now. It could be a reason of conflict. We know that. We've seen the trends of water availability also on the Mediterranean basin, the long-term trends presented this morning so by Valérie. So we see that this is something which is coming quickly as a crucial issue, yes. So it will be much further developed in the future, yes.